I also would like to thank the organizers, Professor Nagler, Professor Facon, my former boss, and Mohammad Moti, Professor Moti. And I also want to thank Arnaud, because the guy has covered 65 slides for you in slightly more than time you were allocated to. And so my talk will be shorter, and I wanted to thank you for sharing some time for me. I will, if we want to talk about Waldenström Macroglobulinemia and controversies, indeed today you're not going to talk about treatment, you are more going to talk on is it time for moving on with a molecular-based treatment decision in Waldenström, and I'll explain that to you in a minute. For everyone in the room, Waldenström is a low-grade B-cell lymphoma, though it shares with other malignant gammopathies the fact that the tumor cells secrete an IgM isotype immunoglobulin. However, it is a low-grade B-cell lymphoma. It has nothing to do with AL amyloidosis and has nothing to do with myeloma, and you should clearly separate the disease in your way of treating the patients. It was shown in the past that the level of IgM does not matter much in the decision of Waldenström. It's a bone marrow disease, and you should perform bone marrow assessment to diagnose Waldenström Macroglobulinemia primarily, although it could be diagnosed in various ways. But if you have looked in the literature in the past years, and particularly since 2012, you have noticed this new mutation that was diagnosed. And I'm happy to see that it was also diagnosed recently in AL amyloidosis, which I'm not necessarily surprised. Then MYD88 was diagnosed by Stephen Treon and published in New England Medicine. It was actually identified in B-cell lymphomas years ago by Luchtout from the US and published in Nature. But for Waldenström, it has never been, since Stephen Treon performed that study, no particular molecular alteration was diagnosed in Waldenström. And in this graph depicted here for you, I showed to you the work from Stephen Treon confirmed by other teams and labs showing that 90%, 92, 95%, depending on studies, of Waldenström patients harbors this unique MYD88 mutation, L265P. I'll come to that next. And in the second part of my talk, I'll cover slightly CXCR4 mutation, because this is also an extraordinarily exciting era of molecular development in Waldenström. So what Stephen Treon has shown was that 90% of the patients had a mutation is the same, unique for all the patients, called L265P, and that mutations strongly activate IRAK and NF-kappa pathways that you know are major pathways altered in the Waldenström disease. There is no, so we know that mutation is certainly a driver mutation, and we know that mutation is now a molecular signature of Waldenström. But the key questions are, number one, still, if 90% of the patients have these mutations, still 10% of them do not. So are those 10 patients truly Waldenström? So are necessarily 100% of the Waldenström patients having this mutation? If you don't have this mutation, then you cannot be Waldenström. Can we say that? Clearly today we can't. We cannot, because some of the patients that are no Waldenström clearly can have MYD88, and we have, it has been shown that high-grade B-cell lymphoma, mantle cell lymphoma, AL amyloidosis without Waldenström, other B-cell malignancies could have MYD88 mutation, though unlikely to be the driver mutation as is likely to be for Waldenström. In our team in France, we showed that you could have other alteration of MYD88, not simply this, not solely this mutation. We have identified other rare mutations. We also have identified that you could alter it and a MYD88 gene and pathway by, for example, having the trisomy on chromosome 3 where MYD88 gene is located, and other. So you could have other genomic alteration to MYD88 that could explain why the pathway is activated without having this mutation. And we believe those 10% remaining patients may have those alterations. Now, still, it's unclear whether these abnormalities are primary driver as to this mutation to MYD88 in Waldenström. The next question we ask, if we kind of want to go into controversies regarding expression of MYD88 and this mutation in Waldenström, is why would other low-grade B-cell lymphoma harbor MYD88? And if they harbor this mutation, does this mutation in high-grade B-cell lymphoma, mantle cell lymphoma, follicular or marginal zone lymphoma, although it's expressed in only 5–10% of the patients, but if it's expressed there, does this mutation has the exact same signaling alteration that it has for Waldenström? And this is unclear as well. I'd like to remind to you that the IgM MGUS patients, you can find in, it depends on the studies, but 30% to 80% of them, this mutation. And it would be interesting to see if, when you have an IgM MGUS with this mutation, if that could drive you to specifically Waldenström, although this is clearly unclear. Very few marginal zone lymphoma, which you know is a primary differential diagnosis to Waldenström, very few of these patients harbor MYD88, but some of them. So are those patients Waldenström misdiagnosed at marginal zone lymphoma, or are those patients truly marginal zone lymphoma? And then what is MYD88 doing there? So you see there are lots of questions around this mutation. Still, that mutation is a primary molecular event in Waldenström, and I'll show to you in a minute that it is now included in the diagnosis criteria for Waldenström. The last question we wanted to ask is there are kind of variants to Waldenström, clinical variants presentations, the Schnitzler syndrome, which is a cutaneous presentation, and the so-called Bignil syndrome, which is a leptomeningeal presentation of Waldenström. And in my team recently, Stéphanie Poulain, Dr. Poulain, she looked at the presence of MYD88 mutation in the liquid, in the cerebral fluid liquid, and we found that it was possible to perform PCR detection of the MYD88 mutation in the BNS, Bignil syndrome, cerebral fluid, and then to validate the diagnosis of Bignil syndrome. And also to use this mutation as a MYD marker, a marker of negativation of the presence of the tumor cells in the fluid, in the cerebral fluid. So this is going to be published soon for you, following the Waldenström workshop in London. There has been a new kind of evaluation. We have revisited the diagnosis, monitoring, and the diagnosis and monitoring checkup that you should perform for Waldenström. And besides all these tests that you must perform, and you know that, and those tests were already present last time, you now have this line that appeared that include testing for MYD88 L265P gene mutation in the workup of Waldenström Macroglobulinemia for the diagnosis and for the monitoring in the future. Now, if MYD88 is negative, you should not consider the patient is no Waldenström, because the diagnosis remains based on histopathology. But of course, the presence of this mutation clearly point to this diagnosis. Now, the second point I wanted to talk about is that there is another mutation, of course, found by Stephen Trion in 10% of the patients. We validated this data, and others have done that too. Clearly, 25–30% of the patients have a CXCR4 mutation. That mutation is extremely interesting because years ago in myeloma, there has been a lot of work around the idea that if you could use an anti-CXCR4 agent and have the tumor cells circulate from the marrow of the patient, potentially you could target the tumor cells better in the regular serum and the circulating veins and arteries of the patients. And Irene Gabriel has performed this work published by colleagues of us, Azab, when we were doing our PhD in Boston, showing that patients that receive the AMD, an anti-CXCR4 agent, in the mice, sorry, I said patient, I meant mice. If you engraft myeloma cells, and then you give AMD, the anti-CXCR4 agent, and then right after AMD plus bortezomib, clearly you were able to very nicely have a decrease in the tumor burden of the patient. So targeting CXCR4 has been something extremely interesting. I don't know if the companies are still very interested in looking into this kind of era of development for myeloma, but clearly CXCR4 was already known as a very interesting molecule. So what about CXCR4 mutation, particularly in Waldenström? So as I said, there has been 25% of the patient harboring this mutation. This mutation induce a cytoplasmic C-terminal tail. Most of this terminal tail in patients for CXCR4 is abnormal. Most of the patients have a stop codon or frame shift. This does not matter much. But what matters is that then the consequence to the tumor cells is that CXCR4 is not normally internalized, and there is no normal desensitization to CXCR4, and therefore all the downstream signaling pathways, and some of them you may know of, PI3K, mTOR, etc., which are very important for the tumor cells to survive and progress and proliferate. All those signaling pathways are highly activated by the presence of this mutation in the C-terminal tail of CXCR4, which makes potentially this mutation interesting. What we found, and thanks to Stephen Trion and Irene Gabriel, both of them, but particularly Stephen Trion, they found out that it's not just about CXCR4 mutation activating CXCR4 pathway and all the downstream pathways in Waldenström tumor cells. It's also that most of the patients having the CXCR4 mutation actually had a more aggressive phenotype. They responded less, the survival was much shorter. But most importantly, and this comes from Irene Gabriel's lab, is that we found out, surprisingly, that those patients were actually less responsive to some of the most important BCR, BTK, PI3K inhibitors. You can see here everolimus and mTOR, ibrutinib, the first BTK in class, idelalisib, the first PI3K delta in class. Each time when you have a CXCR4 mutation, the patients are less responsive to the treatment, which is not the case for bortezomib and not the case for the novel generation PI carfilzomib. So there's something with CXCR4 mutation which is extremely interesting. So if you run the hypothesis that the presence of this mutation could be an oncology collaborative partner to MYD88 primary driver for Waldenström, if you run the hypothesis that this mutation triggers BTK phosphorylation and downstream pathways and makes the inhibitors less effective, then you want to target CXCR4 in the future for treatment. Well, then I must stop my talk at some point, and I'm going to stop with this very disappointing slide, because if you wait data on targeting MYD88 mutation, there is none. If you expect me to show you data targeting CXCR4 in Waldenström, there are none. You're going to have to wait a couple more years. But clearly for Waldenström, there is a move towards systematically looking at those molecular events, MYD88 again and CXCR4, because they help us understand the different clinical presentation. Clearly they impact survival, and clearly they will impact the treatment choice. So how does that change into the new evaluation and guidelines, again, soon published, hopefully, by Jorge Castillo from Stephen Trion's Boston collaborative groups in British Journal of Hematology. As I said, you must perform this mutation, MYD88 L265P, for Waldenström Macroglobulinemia patients systematically now, and it is now strongly recommended to look at CXCR4 mutations, particularly for patients you would want to treat with, let's say, B signaling inhibitor, BCR, BTK, PI3K delta, etc. Now, in my group, Stéphanie Poulain, she has tried to identify all the mutations in all the B most important signaling pathways, from the TLR, BCR, NF-kappa, canonical, non-canonical, and there are so many of them. So clearly, Waldenström is a disease of future molecular personalized treatment decision. And with this, I'll thank you very much and welcome questions.